Hello everyone, here's my project on iris flower classification. In this project we aim to develop a machine learning models for iris flower, and our objective is to predict the species of flower on the basis of sepal length and sepal width measurements. Here you can see that the diagram of iris flower. We have three species, that is iris setosa, iris versicolor, iris virginica. After that we import necessary libraries which are used in this project, like we have to import numpy, pandas, matplotlib, seaborn, plotly. After that we have to read the dataset. We can see that the dataset contains 5 columns like sepal length, sepal width, petal length, petal width and species. After that we have to check the info of the dataset. Like in this we can clearly see that there are 150 rows and 5 columns in this. After that we can check the shape also. In describe you can see that there are the counts of the each column, mean, standard deviation, minimum percentiles and maximum number. After that you can check the null values. In this there are no null values. This dataset are equally divided into 50-50 species of each of them, like 50 rows of iris setosa, 50 rows of iris versicolor and 50 rows of iris virginica. In this we can clearly see that we have to plot the count plot. In this you can see that there are equal number of rows and columns for each of the species. After that we can see that we have plotted a subplot for each of the column, like sepal length, sepal width, petal length and petal width. You can see that the maximum sepal length is around 28 and sepal width is more than 35, that is around 38 approx. Petal length is around 38, petal width is more than 40. We can draw a pair plot also, hue equals to species, in which we get different colors for different species. Like here you can see that sepal length of iris setosa is more than other species. Here you can, in sepal width, here you can see that the sepal width of iris setosa and iris versicolor are almost equal. In petal length iris setosa, length of iris setosa is more than the other species. In petal width, length of iris setosa are more than the other species. After that we can to know the outliers we can plot the box plot. So we have plotted box plot with the help of subplot, so that we can get in one graph like all the box plots. So here you can see all the box plots for all the columns. Like here you can see that the outliers are in the sepal width. So we have to remove these outliers with the help of z-score. We can calculate the z-score that is equal to data frame that we have selected, df minus mean upon standard deviation. Standard deviation is calculated by STD. And we have one threshold to remove the outlier, that is 3. And we have to remove the outliers, and this is the data frame without outliers. We have to merge that both the data frame that is without outliers and the previous data frame which is with outliers. So we will get the merged column from that. So we have to remove the duplicates column. After removing duplicates column, we get the data frame without outliers. And this is the part of machine learning. In this part, we will predict the species of iris flower with the help of sepal length, sepal width, petal length, and petal width. For this, we have to divide the features and targets. In this, we have taken features like sepal length, sepal width, petal length, and petal width. For targets, we have taken species. We can use the head function to know know about the dataset, like target, features dataset and target dataset. We have to import the following dependencies like sklearn.model selection, import train test split. We have to import cross validation score. We have to import accuracy score. We have to import grid search CV. After that, we have imports necessary libraries like decision tree classifier, k-neighbors classifier, k-fold or random forest classifier, logistic regression. After that, we have used train test split method to train and test the data. And from you can also check the shape of train and test data. After that, we will find the accuracy score of all the models which we have taken, like logistic regression, decision tree, random forest, and k neighbors. Here we will give all the models in a list so that we can find them in only at one go. For this we have created a definition, compare train test model. For model in models, we have we have train and we have to fit the model in X train and Y train, and we have to predict we have to predict Y predicted equals to model dot predict. We can take X test. Here you will get the predicted value. Now if we have to check the accuracy, we can use accuracy score, which we can use the Y test, and we have to check for Y predicted value both. So from this you can check the accuracy score. And again we have to run that we have defined that compared model test train. After that we have to check for cross validation score. Again we have given all the models in a list, and we have to calculate the accuracy score, like cross validation score. Cross validation score with the help of we can take cross validation up to 5, and we can directly check cross validation score from this. After that we have to import all the metrics to check the models. Like we have to import accuracy score, precision score, recall score, F1 score, and ROC AUC score. Again we have to fit the model like X train, Y train, and again we have to predict X test. Here the accuracy score will be Y test and Y predicted. After that to check the precision score, like precision, we have to pass the precision score on Y test and Y predicted, and average equals to micro. We have to take average equals to micro. For recall, like recall underscore score, we have to check for Y test and Y predicted value, and average equal to micro. We have to take average equal to micro. For F1 score, we have to take F1 dash underscore score, we have to check for y test and y predicted and average equals to micro. In this way we can check like different accuracy precision we call F1 score and ROC AUC score. In this we can clearly see that logistic regression outperforms other based on accuracy score and cross validation score. Here you can see that logistic regression is 96%, which is more than the decision tree random forest k-neighbor classifier, and cross validation score is also, here is the cross validation score for logistic regression is 97.33, which is greater than decision tree random forest and k-neighbor classifier. After that you can see the precision score also. Precision score for logistic regression is more than any other models, and our ROC AUC score is 1, which is perfect. And so we have to so the best model for this iris flower classification is logistic regression.